But if you see something like let's just look at number 2 for like 1 second. It looks like a log, some adding, and a thing. And if you're thinking, I want to do good on test 3 and I'll worry about the final in a little bit, you can, work this problem, but then maybe hop over to the final exam review, which, heck if I know where it is. Hang on. Where is it? If you hop over to the final review that I already posted, and you go and look for one that looks kind of like it. Like that one had, what did that one have? We said it had a log and adding 2 logs and setting them equal to something. So I might scroll through here and look for one. Like I know this is going to be on both tests, so I might as well look for this to practice and see if there is one like it. Is there? Right, no calculators at all. I don't even see one kind of like it. I guess there's one kind of like it right there, but that's just domains. There's no adding logs? Anybody do the review yet? Mm-hmm. Oh, well, that's nice. That's super nice, actually. This one's kind of like it. Because it has this, it's like reverse. It's like reverse adding logs. So I guess that would be like the best thing to even try. Right? Oh, this one's kind of like it too. They just don't have the adding. They just jump straight to the solving. But we're kind of in the same idea. If we look at this one looks like it has an E and some adding and some solving. I know that one ends up over there. So it looks like it has an E and some adding and some solving. Let's see if we find one with an E and adding and solving. Surely. There you go. Look at that. There's an E with some adding and some solving. There's 4 problems to practice for test 3 and the test. So today we'll just look through this test 3 review. Tomorrow, or next week, we'll start with that final review, really working through all of them. All right? Yeah, so it's we don't have to go in order. But we can. But if you just walked in and you want a piece of paper, there's extra papers. I just printed out a bunch of them. So if you want a review, you can grab one. Feel free, take 2 if you want to practice it again on a blank paper. If you look through real quick, take a minute, look through it, find something that looks too crazy to do, and I will open up a new folder or file so we can work through it. So take a minute to look through and really find something that looks impossible, and then we can look at it together. Yeah, that's the hardest one. The first one's literally on here because it's the hardest one, and it's the hardest one in the final, too. This is the hardest type of problem. Technically, ooh, I didn't mean to put all those pages there. Yeah. Yes. All right, let's see what this looks like. Number 1 says factor the following. The first thing I would try to do by far, like before I even did anything else, the first thing I would try to do if I saw number 1? The very, very first thing, if it just said factor something. What? What's C? Ooh, it is missing a term. Dang straight. I didn't even notice that. It's missing a final term, right? It's missing this +4 at the end or whatever. That's a good thing to notice. That actually clues me into what I could do to make it a little simpler. Yeah, you can set it equal to 0, but before that I'm thinking what you just said makes me think I could do something to make it a slightly simpler problem. Yeah, if you divide it all by x. Yeah. Well, actually, before I even do anything, I know a 0. I can divide it all by x, and we should. Like what you're saying is take this and go technically we can factor out an x from every single thing and just shrink it a little bit. Makes our life a little bit easier there. But what that does is give me part of my factor. Like, part of my factor is already done. Just imagine this in parentheses, and that's a nice little parenthesis that's factored. If you want to think of it as what it is, it's technically x minus 0, isn't it? If you're thinking of it in x minus c's, like all the factors we do. But nobody ever writes it like that. Okay. Well, now it looks like I can group it, factor by grouping. Or at least it looks like the type of thing where you get to group. But does it group nice and neat? I don't think so, because 13 and 15 seem terrible. 13 and 15 are not have any factor in kind of in common. So that means we got to do it the long way, which is not fun, but is important to know. Remember this TC over LC thing? And I did clue you in and say it's always going to be one of the nice easy things, like 1 or 2, or -1 or -2. So let's find out. What are some factors of the trailing, or actually, what is the trailing coefficient? -15 over 1, and that turns into all of the things that can multiply to get you 15.
1, 3, 5.
Plus or minus 1, plus or minus 3. There's one more. And all the things that can multiply to get you 1 are just plus or minus 1. I believe, I could be wrong, but I believe there's something on the final that just does this. And like, that's your answer. I could be wrong, but I believe there's one on the final where it asks you, those aren't technically roots. What are those technically called? Yeah, same thing, yes. But they're not technically zeros because there's not that many of them. They are possible roots or zeros. And you can say either of those things. They're possible, rational. Wait, no, they're not even rational. Well, yeah, they are. Roots. Those are the possible rational roots. Kind of fun.
If we didn't have one on the bottom, we had like 2.
Set. If you had like 2, then it'd be like lots of fractions happening. Or 3, it'd be a ton of fractions. Okay, so I think we should just try 1. 1, backwards L. And I'm using this thing. I'm not using the big thing. I'm using the smaller thing just because it makes my job one thing shorter, right? I don't have to throw that 0 at the end. 1, 3, -13, -15. Drop down the 1. Move it over. 1 times 1 is. 3 plus 1 is. 4 times 1 is. 4 plus -13 is. -9. -9 times 1 is. Not going to work. I don't even ever do that last one. I just put an X there. Try -1? Did you already try it? Oh. I was hoping you. -1 gives me 1, 3, -13, -15. Drop it down. 1 times -1 is -1. +2. Oh, shoot. -15. +15. A big old 0. That's check. Okay, here's the thing. This is the important thing. This is the thing that it was where it's so easy to mess up. The positive and negative signs are hard. They're easy to mess up. As soon as I get that 0, I think it's I do this thing. As soon as I get that 0, I go write something right away.
X miles.
Where?
In the -1.
Boom, boom. Every time, even if there's a negative sign. Because that tells me what my factor is. That's my factor right there. So my factor actually technically is x plus 1, right? That's my factor. But my root would have been -1. It's kind of weird how they flip-flop like that, but it's important. Okay, so now what we got is f of x equals x times x plus 1 times whatever we go back here and fill this all in. X squared plus x minus 15. X squared plus 2x minus 15. What's up? What's up? Wait, 15 has 5 and 3 then. 15 breaks down into positive 5 and negative 3. So then we get f of x equals x plus 1, x plus 5, x minus 3. Right? Wait, no, that's right. I thought I messed up. So what are your zeros?
-5 and positive.
Negative 5. There's 2 more.
Positive 1.
0.
Oh.
Careful. Okay. What did it say? Factor the following. So, great question. Freeze. Great question. Let's find out. Let me go find out. Because I don't know how they would even ask that multiple choice wise. And if they did ask it multiple choice wise, I've got another thing for you to do when you don't know how to do that. Hang on one second. No, it's even easier than that. So, use the rational zero theorem to list all possible rational zeros. That is one. Where it says list all possible rational zeros. That's the thing we did where you just boxed the thing.
Oh.
So actually, I might have just said, hey, go farther than what the question's asking you for in the review. The question asked you for that first box, but it's still good to know the rest. Find a rational zero and find all zeros based on that. No, there is one where they ask you to do the whole thing. But here's the thing. If they give you that list, you're right. They gave me that little list, and it was only 3 instead of 4 in that case, the one I just looked at. It wasn't 4 individual. It was only 3. But if they give you this list in the multiple choice, what can you do? If this is a multiple choice list, what are these things supposed to be? Roots, x-intercepts, 0. So what could you do with this? Let's take the easy one, 3. And what should you get if you plug it in? 0. So you don't even have to do any of the math. If you just take the answer, if it says find all the zeros and you forget completely how to do it, just grab the multiple choice answer choice and plug it all in.
So any of them would equal 0? Like choosing any, like applying any of them would equal 0?
Yeah. Oh, absolutely. And if it doesn't, we did our math wrong because that's what they are. If they don't, like 0 definitely works. I can look at it and see.
Equation should
Give you 0. And if you get one of them that doesn't, then it's not the right answer choice. Scratch it out. That's kind of, yeah.
What did you put? An x negative of this.
Right here?
Yeah.
To give me this and this.
But why is it negative?
Just is. It's always x minus. The reason why is the same reason why if you look at a long time ago we did that complete the square formula where we said the vertex is where a horizontal shift is opposite of what you would think. It's because the intercept, the x-intercept is opposite of the factor. Well, the x-intercept is the number you plug in to get 0. So if my x-intercept is 3, and I plug 3 into this, I'm just trying to make this as simple as possible. If I know my x-intercept is 3, and I plug 3 into this normal thing with the same sign, what do you get? 6. That's not a 0. You change that sign. If I plug 3 into there, what do you get? Now it's a 0. That's where the flip comes from, is that it's actually like the factor flips the sign from the intercept because you're trying to get back to 0, not just write your x-intercept with the plus sign in the thing. So that's why as soon as I get that thing, I always go up to the top and I write x minus so I remember what my factor is. This is the 0. As soon as you get the 0, as soon as you get that 0, then you can say -1 is a 0, which means that x plus 1 is a factor with the flip sign. That's just this process of stepping. Yeah.
Where did you get that 0 from when you listed on your x-intercept?
From this one right here,
Oh.
which is technically x minus 0. Yeah.
So that one is always going to be.
Well, it's not always there. It was just.
If there's an x by itself.
Yeah. All right.
And if you get x equals 1, then
All right, let's look through this thing and find some more difficult problems. Find some other ones that are pretty tough to solve.
8.
8? Okay, 8 is not hard, but if we don't know it, it's almost impossible, right? It's like it seems like it should be pretty darn easy, but by golly, we need to know the steps / the rules or whatever you want to call them. Okay, so here's what I do. I'm going to make this as easy as humanly possible for us. And, freaking move.
Log 5 of 5 is -1.
No. I'm not going to do any of the steps or the rules or anything. I'm going to say anytime you see this log, make this as easy as possible. Which one's the base? For both of them, they're the same this time, but they don't have to be. Where's the base?
5.
Okay, this is how we're going to make it as easy as possible. The base is 5. Okay? Don't even look at what's in the other thing. Don't even look at it. Just take your 5 and write everything you know about 5. What's 5 to the 1?
5.
What's 5 to the 2?
25.
What's 5 to the 3?
125.
You can stop at 3 every time. Okay, there's 3 types of things. That's the normal thing. What else could the exponent have been?
Negative
Sure. 5 to the negative 1 is.
105.
5 to the negative 2 is.
125.
5 to the negative 3 is.
125.
So now we're not having to memorize any rules or nothing. As soon as you see the base, you're just writing everything you know that has a base of 5. There's one more set of things.
When you have a fraction,
Yeah. 5 to the 1/2 is.
basically,
Ooh.
2.5.
No.
Square root of 5.
Root 5.
Yeah.
5 to the 1/3 is.
Cube root of 5.
Cube root of 5. Those aren't going to be our answers for sure. I can tell already just by looking at them. Okay? So that's what you're going to do. You're going to take your base and you're just going to write those 9. If it's a 2, if the base is 2, you might have to go a step farther and go to the 4th thing, which is 16. Like, I don't know 5 to the 4. 625? No.
5, 5, 25.
I don't know it. What I'm saying is I don't know 5 to the 4 in my brain without a calculator. 125 times 5? 725?
No.
It doesn't matter. This doesn't matter. Who cares? I trust you. What a waste of time. Someone else should have done this already. Did you get it already?
Yeah, it is. It is 625.
It's 625. I should have actually known that. You don't have to know that. You might have to know 2 to the 4th, which is... No. That's 2 times 4. Why would they invent 2 different things that do the same thing?
I thought 2 times 2 is
4 times 2 is... Times 2 is... Yeah, there's one extra one. So you might have no 2 to the 4. All the other ones, you can just stop at the 3. Okay? Okay. So now the question is, where's your 1/5 at? Boom, boom, boom. There's your answer, -1. Where's your 1 over 125? Boom, boom, boom. There's your answer, -3. You're done.
So log 5 of 5 cancels.
Log 5 of 5, it turns into 1.
Yeah, 5 of 5.
Yes. Log 5 of 5 equals 1.
And if we get 5 log 5, it cancels.
5 log 5 of x turns into x. Good little notes to make as you're studying. I would do that. If you're studying things and you want to try to remember all those little random rules, it's always fun to do because then you're just making sure you know what's going on. Absolutely. Oh, yeah. I'll move it down there just for consistency. But this one's super short. Again, just like a easy, but you got to know the rules type thing.
Yeah, that's one tricky thing.
It's not tricky.
But isn't technically what we would do? Log base here?
Well, how do you...
Or ln?
Yeah, how do you get rid of... The question to ask yourself is, how do I get rid of any base? Not just, bless you. How do I get rid of any base? If I have a random thing called a to the x equals, I don't know, call it 100, how do you get rid of that a?
You log it.
You log base a it, right? And it cancels it out? Okay. So how do I get rid of an e?
You log ln it.
You ln it. Ln's the opposite of e. ln.
Or log base
But for the history of math class forever, ever, ever, you can't just do something to one side randomly. You absolutely have to do it to the other. I'll write it like this for now. So we should end up with ln of e, all that crap, equals ln of 5. One nice thing happened. Boom. X plus 2 equals ln of 5. We're almost done, but I think we need x by itself. So don't be a hero. What's ln of 5 minus 2? I don't know. You don't know. None of us know. You don't need to know.
Wait, why does the ln and the e cancel?
Oh, that's just from the definition of ln, which is only literally saying that ln is literally defined as log base e. Like literally, that's what it means. They just made a special one.
So natural log and
So that means that the ln of e is 1. That means that the ln of e to the x is x. That means that e to the ln of x is x. Because every time here, they're canceling. Those canceled, turn into that invisible 1. Those canceled, turn into that x. Those canceled, turn into that x. There's one more. Can you remember? Oh, I got it, but I'm not going to say it. There's one more ln property. The ln of blank equals what?
1.
Equals?
Log of 1 has 0.
Ding, ding, ding. Perfect.
I have a question.
Yo.
So you know how the way I solved it, I put the exponent to the front
Okay.
because that's one of the rules of the theorem.
No. I got you. I know what you're saying. Oh. After you did the ln stuff. Or before you did the ln stuff. That's not the rule. Good. I know exactly the rule you're thinking of. That rule? Yes. That is a super good rule, but that rule only happens if you have log or ln. So you're allowed to do that instead of doing this cancel thing. You're allowed to do that right here on this step where you take this exponent and you move it to the front. And now what happens there, ln of e is, what's ln of e? It doesn't cancel, it's something.
1.
It's 1, right? And now you've got the same thing we have right there. So it's just, but you can't do it before you throw that ln or the log in the mix. The log or the ln is the rule, not just for every exponent. It'd be sweet if it was every exponent. That'd make life a lot easier back in the day when we used to do like x to the a to the b, because then we'd just be yanking that b to the front and be like b to the xa.
So it only works for
Log.
and ln, not for ln and e.
No, it would work for ln and e. It just, no. It just can't work before you throw the ln in the mix. I can't do it right here. Look, on this first step, look. I can't just do this.
I have to cancel out first.
Well, you have to just incorporate an ln or a log. Heck, you don't even have to freaking do an ln. You could do a log. It would just be ugly. But you could do a log. I could log both sides, not ln, move that to the front, end up with x plus 2 is in the front, log of e equals log of 5. That's me logging both sides. Then I'd move that log of e over, right? X plus 2 equals log of 5 over log of e. Subtract 2, you'd end up with the same answer. Promise. But no, don't do it. Yeah, no. If you have the ln, use the tool. But what I'm saying is that rule that you said could help us do that if you didn't have the ln. Oops.
I mean, it's still good to know if you're on a cliffhanger and you need something to help you out, it can help you out, right?
Yeah, it's also just the proof of that change of base formula, which is top minus bottom. Okay, there we go. Cool. All right. What else we got? Number 2. Love it. Another one. Yeah, these are great. This is the majority of this test will be these log rules. Okay. This one, I think, is just one special rule that needs to happen. But yeah. But while we're on that special rule, it might be worth just saying all the special rules. I think there's only 3.
If there's multiplication on the inside, there's addition on the outside.
Multiplication on the inside.
Addition on the outside.
Love it.
If there is division on the inside, there is subtraction on the outside.
Talking faster than I can write.
And if there is an exponent, you will do the front.
Which is technically like saying multiplication. Because they all just drop a step. They all just drop one step before what they were. Those are the 3 rules. So one of those gets applied. Now they don't work backwards. We have 0 clue what to do when you get log of a plus b.
Yeah, that's something else.
Yeah, don't even try. I know it's so easy to forget which one's which. It's so easy to say like, oh, there's plussing. Let me just do something. No. These are not like, this and this are very, very, very different things. Heck, if you can add a and b, just add a and b. If it's like 3 and 5, just make it log 8. Like if you can do that, do it. But if you can't do it, don't try to be sneaky on them. But okay, so let's see which one of those applies. Yes, absolutely. 8, good to go. Mash them together. Log base 8 of 2 times x equals 1. That's kind of like saying log base 8 of 2x equals 1.
Can you do it like log 8 parentheses 2 and then log 8 parentheses x?
No, those are 2 different things.
Would
Good question though.
Question.
What?
Would you be able to take log 8 perhaps, and then do 8 on the same other side or something?
So when you say 8 it, what do you mean by 8 it?
Like put 8 in front of log 8.
Not in front of, but
Multiply.
not multiplied by, but how do we get rid of that log 8? You're going to do it. I know you're going to do it right on your paper. I just want to figure out what the word is for that thing. You raise it by
8.
a base of 8. You make the base is what you're doing. They're the same word. You make the base. Boom. And I even put that caret there so I don't forget that I'm not multiplying. I always put that caret there. You don't have to in normal life. Usually we never do, but just so I don't forget that I'm doing it and I'm not just multiplying by 8, you make the base. But what you do to one side, you have to do to the other side. So make the base. Choo. 2x equals 8 to the first power, which is just 8. Which means that x better be 4. Cool? Okay, let's keep going. Getting some good reviewing. What else we got?
9. Oh wait, somebody else said 4 first.
Oh, okay. Let's hit 4 real quick. 4 is pretty darn similar, and then we'll do 9. Solve this. All right, let's work through this slowly. Oh, shoot. They're being sneaky. This really is them trying to be tricky and getting us to jump straight into the L and stuff without seeing a very easy, like 8th grade thing that could happen. Like a back in the day thing. Yeah. Don't try to be so sneaky with the ln of the e and everything that you miss something very like 35 minus 8. That would be really sad to jump in. So you get e to the negative 4x equals minus 5 minus 3. Thank you. And then we kind of just talked about this a second ago. How to get rid of an e.
Log or ln.
Or log, if you want to log e. Hey, if you want to write it as log of e, I'm not judging you. But I write it as ln because it's less things to write. And what you do, whoa, nope. What you do to one side, you have to do the other. So we have ln of 27. Okay. Negative 4x equals ln 27. Oh, we're like done. How do you get x by itself?
Divide by 4. Negative 4.
Boom, boom, boom. Home free. You want to see something even cooler? That I don't know which. This is the way they would write it on the test on multiple choice right here. I'm gonna circle this. But there's a cool thing you can see. If your brain is really thinking in terms of all the laws that we've studied, there's a really cool thing to see here.
Subtraction, right?
No, this is kind of the same thing as 1/4 times the ln of 27. Negative, my bad. Right? Right?
Oh, yeah.
And there's like a little rule we have where if it's in the front, it could also be up here. So now I've got ln times 27 to the negative 1/4, which is ln 1/27 to the 1/4, which is ln 1/4 root of 27. No, you wouldn't do that. I just think it's the red thing would be the multiple choice thing. I'm just saying, like, it's good to know. I don't know why. It's just good to be able to do that little puzzle building. It's true. That follows a sequence of steps of different identities that we need to know. Like, this can go to the front, and the negative sends it to the bottom, and the 1/4 is the same as the cube 4th root, quartic root. But that's not your answer. The red box is your answer. It's just also true. All right.
We try number 3.
No, someone said 8. Or,
9.
thank you, sorry. Oh, why is this on here? This is not pleasant.
Isn't that the horizontal thing?
Oh, well, I actually don't know yet. We just have to graph it. This is just like old school. All right, here we go. Well, there is one. There's a bunch of stuff. There are 5 things. If it asks you to graph something, I'm not saying it will. I'm fairly certain test 3 is multiple choice. But graphing the rational function, if they do ask you to graph something, I'm here. We have plenty of extra time. And it's on the final for sure. So there's like 5 things to do. 5 things to find.
Zeros, the y.
Vertical asymptote, horizontal asymptote. I heard zeros.
The y-intercept.
The y-intercept. Should be one more thing, but I don't know it.
It's not
Line, points, point.
It's not domain, right?
Maybe that's it. Test points. Just test points if we run out of things.
Yeah.
If there's some sections of the graph that we don't know, we might have to throw in some test points. Let's see. Which one do we want to do first?
The
My- Yeah, you can do that. My easiest is literally the y-intercept, though. The y-intercept is so dang easy. You literally plug 0 in, right? The y-intercept is literally f of 0 equals 0 over negative 2, which is 0. So that's the point 0, 0. Like, that's what you don't have to do it first, but that's what I do first because I'm like, I can plug a number in. And then, yeah, I think horizontal asymptote is the next easiest thing. So the horizontal asymptote had 3 conditions based on the first thing. Based on our leading terms here. Bottom bigger means. Yep. Means y equals 0. Bottom bigger, you can just think going down because going to the bottom. Going to 0. Top bigger, going up, going to infinity. What? No, it's true.
So does it mean?
No, that's if the top's bigger. It's going to infinity super fast.
Oh, you look at the exponent.
Yes, yes. Oh, yeah, yeah. You look at the exponents, not you were looking at the coefficient 2 and 1.
Oh, you look at all it.
You're looking at the exponents, not the coefficient. Sorry, I should have written bottom exponent bigger. But if the exponents are the same, then your brain hops to the coefficients and takes that fraction. Like you can cancel out the exponents, like x2 over x2. Then you could look at those. And then your vertical asymptotes are
They cross.
where the bottom equals 0.
Yeah.
So x squared minus 2 equals 0. X squared equals 2. X equals root 2. Plus or minus.
Those are my.
So then we go to this graph. And I say, okay, here's negative root 2. Here's positive root 2. Draw some vertical asymptotes there. Where's my horizontal asymptote at? 0. Got an x-intercept at 0, 0. Got a y. Oh, we never found our x-intercept. Well, I guess we did. That's all that I know. I think we got to plug in some points then.
Wait, say x. Wait, we didn't find our x-intercept.
How do you find the x-intercept?
Equal to 0.
Yep, you say 2x over x squared minus 2 equals 0, which means 2x equals 0, which means x equals 0. So we did technically already find it.
So there's no 0.
But there's 1.
0.
It just happens to be the same as the y-intercept. I think we just got to plug in a bunch of points. That's not fun. I guess 1 and negative 1, yeah. Here we go. I'm going to start like a little, I'm going to start a table. I'm going to start a table right here. You plug in 1, you get 2 over negative 1. So negative 2. So that would be 1 comma negative, that'd be down here. You plug in negative 1, what do you get? Same thing. Oh, flip it because the top. So I think I can tell what the inside's going to look like already. Look like that S curvy thing. All right. Now what number on the outside do we want to plug in? It's got to be bigger than root 2, so just 2. Is 2 bigger than root 2? Yeah. There's a moth. 2 gives you. Wait, is 1 smaller than root 2? Yes, it is. Because the 1, that would be root 1. I'm dumb. Yeah. Just making sure. 2 gets you 4 on the top, divided by 2 on the bottom, which is just 2. So that's up here. So we get this. And then negative 2 gets you negative 2. So that's down here. It looks like that. This is x comma y. That's fun. That's so cool. So I guess there really are only 4. I guess the 5th thing would be technically test points. Because we did end up needing a lot of them there. So those are your 5 things. Vertical asymptote, horizontal asymptote, zeros, y-intercept, test points. Starbucks for life is back.
Wait, the vertical asymptote would be us taking the denominator equating to 0?
Yes, every time. Vertical asymptote, set the denominator equal to 0. Horizontal. Zeros, set the numerator equal to 0. You don't even have to worry about the denominator. So your x-intercepts, top equal to 0. Horizontal asymptotes, bottom equal to 0. They both start with you putting a little dot on the x-axis. One you just go shoop, and the other one you just put the dot there.
So
And if it's bigger on the top, to infinity. And if it's the same, then where you put that horizontal line is the coefficients. Like in this case, it would have been 2 over 1. If they would have been the same. If this would have been a squared, then those end up canceling out, and you're left with 2 as your horizontal asymptote.
Oh, so 2, like the line 2 itself?
Yeah, y equals 2. All right. Somebody asked for y that wasn't 9 after 9 was asked for. Number 13. Number 13 is good. Yep. Hint there are 2. That's a good hint. That's easy for me to miss. The hint is easy for if there's a hint. If you ever see a hint, it means that as I was working it, I forgot it. That's literally what that means. It means I was working it for the first time and I was like, oh man, I forgot. There's two answers, not just one. Okie dokie. We can start by getting rid of that 5. And how might we get rid of that 5?
Basically raise it to the base of 5.
Boom, 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 boom. Just like that. Sometimes I just say like 5 it, but that's not true. Exponentiate it with a base of 5. It's better. Make the base is good. Raise it by a power of 5. Good way to say it. I don't know. There's lots of different ways to say it, but that's how you do it. Cancels out, and you're left with x squared minus 4 equals 5. So that means x squared equals 9. So that means x equals. Look at the dang hint. Plus or minus 3. And you know what I need to do? To check and see if there's actually 2? Actually plug it in and see, is this possible? So we've got the log 5 of 3 squared minus 4 equals 1. That's the log 5 of 9. Oh, look at that. That makes sense, doesn't it? Would putting a negative 3 in there change anything?
No.
Because you're squaring it.
Yeah.
Yeah. Okay. So if we check that out, I'm just going to copy this and just watch this. Boop, 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 boop. But instead of that 3, you know what I'm putting in there? Negative 3 with parentheses, which just turns right into that same 9. So it does check out. These are all good. What's up? Ooh, number 3 is sneaky only because they always like do one slight sneaky thing. The only reason it's sneaky is because it looks like I can see a lot of people just jumping in and doing a thing right off the bat that you're not technically not allowed to do. Can you see a thing that a lot of people would be like, "Oh, I want to do this"? Yeah, like that's an instinct, right? No, it's okay to acknowledge like that looks like I should be able to do it. The reason it looks like I should be able to do that is because usually in math, if I had a 2x squared plus 2 equals 2y, you could reduce all those. You could turn that into, you could do that usually. But ln'ing something or logging something isn't multiplication. It's a completely different thing. If it were just multiplying a thing that's called ln, that would work. If this were literally like multiplying some random thing we don't know called ln, that would be okay. But it's not multiplication. It's its own weird thing. So we have to take into account this minus sign is the most important thing on the paper. That minus sign turns us into something on the inside. Indeed. Actually, I'll make that blue. That blue minus sign on the outside turns into division on the inside. But the minus sign on the inside doesn't turn into anything. It's just there. We can't. It's the same as a plus. It's just there. We can't do anything with it.
Would it be okay for us now to raise ln to the power of what, base of E?
Base E, the whole thing?
Yeah.
Ooh, and look what happens. Phew, phew.
Wow.
Before I keep going, I want to make myself a little handy note in my brain. What's the handy note to make in my brain? I just think this is such an important note to make anytime you get anything that looks even kind of like this. I'm not before I solve. I'm not trying to solve. I just saw something bad, and I was like, "Ooh, I need to make a note of this bad thing just in case."
Oh, we can't.
What about it?
Not
Zero. It can't be zero.
It can't be 0, which means something specific about my answer.
X cannot be 5.
X better not be 5. I don't know if it will be. It probably won't be when we get done with this. It probably won't. But I always make that note to myself just in case. What if at the very end of the day it was perfectly exactly 5? I'd be like, crap. It's not possible. So now we'll keep going. Now that we've made that note, we'll keep going. And I'll probably multiply both sides by x minus 5. And you get x minus 3 equals 5x minus 25. And then probably say 4x on one side and 22 on the other. Unless I'm wrong. No, I'm right. And then probably say x better be 22 over 4, which is 11 over 2. Is that 5? No, but it's 5.5. It's kind of funny. That's fun. I guess this is a fun side note that is good, is the domain. Well, I guess there's no domain if you set it equal to something. No. Just thinking about the domain of ln is important. Knowing what x can be for your natural log is important. Yeah. It can be a fraction. It can be 11 over 2. It can't be a negative number, and it can't be 0. So that's what I would say. It's like, it is important to think about your domain, especially if they were going to give you one that didn't have this right side. They could just say, what's the domain? Now it's a super possible problem. Ooh, 11's pretty important. 11 looks easy, but it might not be obvious. Yeah, I just saw it and I thought, it looks like it should. Chill. Well, hang on. Oh, it's up there. Whoops. How to solve the log of 100x. What? Oh, just write it so we know it. Boop, 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 like that. What do you mean add it? We're breaking it apart with an addition sign? Yeah. Yep. Okay. Now what? 100's technically the same thing as. So that gives us 2 plus log 10 of x. And when you see it on the multiple choice test, you know there's going to be one little difference when you see it to select. The difference will be this. Not too crazy. Okay. Keep looking through.
Number 5.
Oh, shoot. Yeah, that's a good one. That's one that we just like breezed over on one day, and then it didn't even kind of relate to the other two sides of it. This was a random one that happened on one day, and it had nothing to do with the things on the other sides. So it was like, okay, well, yeah. It's good to be here, but hard to remember. Paste. Solve the inequality and graph the solution set on a number line, not on a graph. Huh. Perhaps.
Will we technically do it like
Move the 3 over?
yeah?
Then factor it?
Yeah.
You said 5 and -1? Yep, I agree. Now what? Graph it on a number line. So what points are we plotting?
-5.
So boop, boop, boop. There's -5, -4, -3, -2, -1, 0, 1. I should not put a hollow dot there. That would be bad. 0. There's 1. And now I need to know which way to go. There's 2 ways to do it. That's the easy way to do it. That's the easy way to do it right there. Happy parabola, right?
Yeah.
So it's a happy parabola. And so which of the 3 sections do I highlight? The inside. Why this time on the inside?
Because it has equal.
Because it's no, not because it has equal.
It goes down.
Because it's less than. That means less.
Oh.
And so that's saying this is less than 0 down here. So what that looks like is like this. It looks like this right here. Boop, 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 boop. Boop, 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 boop. Boop, 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 boop. If you don't like that way of doing it, that is literally okay. Just grab 3 points and plug them in. Just grab the point 0 and plug it in. Say, what is f of 0? What is f of -6? What is f of 2? And we'll find out. Looks like f of 0 would be 0 squared plus 0. Well, I'll write it out. Plus 4 times 0 minus 5 equals -5. Is -5 less than or equal to 0? Check. That means it gets shaded. That means this middle is getting shaded. What about 2? 2 squared plus 4 times 2 minus 2. Whoops, I did the wrong thing.
Minus 5.
Yeah, I guess you could technically do minus 2 compared to 3, though. 4 plus 8 minus 5.
12 minus 5, that's 7.
Is 7 less than or equal to 0?
Nope.
Nope. So nothing over here gets shaded. -6 gives you -6 squared plus 4 times -6 minus 2. Nope. 36 minus 24 minus 5 is 12 minus 5 is 7. Is that less than or equal to 0? Heck no, it's not. If you don't like the parabola, you're welcome to just plug in points and check. But if you do like the parabola, then it's really important to note that sign because the problem does change if it would have been x squared plus 4x minus 2 is greater than or equal to 3. That changes which side you highlight.
Outside.
Yeah, you do the outside this time. So it's important if you're doing the parabola thing to really know what's going on, how to read the math symbols are important.
One quick question.
The things will look like this on the thing. Like, see that thing right there? That's not telling you what the problem is, but they'll look like that so you know what to do. So if you just want to draw a parabola on the answer choice to be able to check it, by all means, draw a parabola on the answer choice to be able to check it.
Quick question.
Yo.
Would it be cool if we like take like for instance x plus 5 less than or equals 0? Would we get back
I'm listening. X plus 5 less than or equal to 0.
Like we take like the factors and equate like basically how we treat it if we're doing like finding the roots.
Well, yeah, so what's your question?
It's like I'm trying to see like it says if we did it that way, like
X plus 5 is less than or equal to 0. I hear you.
what would it be saying like x is less than or equal to -5?
Oh, X is less than or equal to negative 5? Well, that doesn't work. That's not true. I see what you're saying.
So we don't look at it that way.
No, I'm not doing that.
Sorry.
It didn't work. Only because it didn't work. I see what you're saying, but it,
I have a hard time wrapping my head around this part. Like, I'm trying to see how you actually did the graphing theorem.
the parabola?
No, the graphing, like knowing where the overlaps happen, like basically right here. How do you know when to turn it this way?
Instead of facing outwards?
Like, yeah.
Because when we plugged in, look right here. Look at this blue line. Okay, so right here, this number gave me x equals -5, right?
Yeah.
And this gave me x equals 1, right?
Yeah.
That helped me plot this blue point and this blue point. Okay? And then my brain draws this big old line all the way through here and says, I better check a number in the middle. I better check a number on the outside of the line. And I better check a number on the outside of the line. And this was good. And these were bad because it's not true. So they all got X's. You don't have to check every number. You only have to
So
check.
we wouldn't follow the condition exactly.
Yeah, it didn't follow the condition at all. Even a little bit. 7, it will never be less than 0. It's not even close. And 7 will never be less than 0 on that side either. So, and you don't have to check all of them. Only one has to fail for you to know it fails. Because that's a line, and a line can't ever come back and cross that again. This plus can't cross here again. Because there's no other point for it to do that at. So if it fails once, it fails forever. Above the line. Noah, Deborah, Jonathan, Esther, Natalia, Quang, Ilse, Ciro, Amada, Hector, Cecilia, Braylon, Nelson, Kimberly, Van, John, Jack. No, neither way. Evelyn, Juliana, Tyrese, Yadira, Isabel, Joseph, Lyra, Muna, Gildardo, Caitlin, Alan, Leo, Maria, Aldo, other Leo. I got you. So, yo. All right. If you're happy to go, you're welcome to go. If you want to stay and work another one, I'll stay and work another one. Or 2 or 3.
I'll stay and work another one.
Yeah. Feel free. Which one you got, Joseph? Or are you gonna look for a good one that we can do?
Alright, still on this vertical asymptote and horizontal. I'm trying to ensure that I click memory. Like you said, the horizontal asymptote would be like.
Yep. Top bigger, bottom bigger.
And if it's the same in this or in exponent, it's like basically
Would be 1.
1. Okay.
Yeah.
But the vertical asymptote would be.
Some people missing. All right. So yeah, if you look at number 1, the first thing your brain probably thought was like, oh, this looks like one of these things, right? But then pretty quickly you see that 13 and that 15 kind of screw it up. Like, there's nothing that takes out a 13 and 15 real nice and neat. So that doesn't work. So what else? Yeah, that whole thing, right? But actually, before we even do that, I see one extra thing that's kind of cool. There's something that's cooler about this than normal. Or not cool, I guess, if you don't. There's something different about this one than normal. Yeah, there's an extra X. Usually we have like a +7 at the end or something random like that. And now we don't. So let's just take an X out. Just because it's an easy step. That'll save us a whole term when we do our synthetic division. Like if we didn't do that, we just have an extra. This just saves us one line of synthetic division, which is awesome. You get x3, 3x2, 13x, 15. Oh, well, can we group that? Can we group that thing? Or not there. Whoops. Still no. Rats. It'd be cool if we could. All right, so now we got to hop over to that thing where you do like the TC and the LC. And you got to remember what they stand for, which is 15 is your TC, right? And this invisible 1 is your LC. So you get 15 over 1. But it's not just 15, because that would mean factoring is the easiest thing in the world. Yeah, it's like plus minus 1, plus minus, not 2, because 2 doesn't go on 15. I almost wrote 2, or I was in the middle of writing it. Dummy. And 15. And technically there's a plus minus 1 on the bottom, but it's not doing any work right now. Okay. Well, now we just have to pick any of those random ones. Anybody have a hankering as to which one's going to work? I'll try 1. 1 backwards L. And we're just using this since we already factored out that thing. We're just using this to do the... So we get 1, 3, negative 13, negative 15. Drop down the 1. 1 times 1 is 1. 4. 4 times 1 is 4. Negative 9. Negative 9 times 1 is negative 9. Frick. That. Didn't work. Crap. The whole thing's bad then. Alright. Well, we gotta try another one. 3? Did it work? Did you try it? And it worked? Oh, cool. Told you it's gonna be one of the first 2 every time, especially if you're taking a test. It'll be negative 1, 1, or the next 2. It'll be the first 4 things you try. Usually positive as well. But 3, backwards L, 1, 3, negative 13, negative 15. Drop down the 1. You get like 3, 9, 20. Whoa, did I go too fast? No? Yes? 27. Did I mess up? That's 6. I'm dumb. 6. I need 18, negative 5. 15. 0. That's the important thing right there. That 0 is the important thing. Put a check mark. And as soon as you get that 0, as soon as I get that 0, I write something. As soon as I get that 0, I'm going to write something that's going to help me remember in the future. Yeah, boom. X minus. I don't even write the 3. I just write it right there. Even if there's a negative sign there, I write it so I remember to flip it to positive. As soon as I get that, I write that right up there so I don't forget that's my factor that I just arrived at. So now we've got 2 factors. We've got f of x equals x and f of x equals x minus 3. And we're left with x squared plus 6x plus 5. Is that a nice, neat factor? Looks like it to me. I think 5 and 1, yeah? So now we got x plus 5, x plus 1. That's the factored. That's fully factored.
Yeah, that's why I'm wrong. Because like, if we were missing x cubed, we were putting a 0, right?
If you were missing x cubed,
Yeah, we're putting a 0. So instead of rewrite that, I just put a 0 instead of the last number that missing, and I would still have to like divide that 8. That's why I'm wrong.
I see what you're saying. Interesting. That's interesting.
Yeah, that's why I'm wrong.
Yeah. So I guess that's technically not your trailing coefficient then, because there's nothing attached.
I still have, because I had x cubed plus 6x squared plus 5x plus theoretically 0.
So then if we never would have factored out an x, if we never did that in the first place, would it have worked with the same trailing coefficient, leading coefficient?
Like the x minus 3 worked, but like after that I cannot find another equation like for the second part.
It's probably because if we go back and look, I'll do this in a second as we're looking for another problem. One of the preconditions for doing this whole series thing, which never occurs a lot, is to make sure there's no common factors. So not only is it important to pull out that x, but if there was a 2 in common, we probably would have wanted to pull it out as well. Yeah, I see what you're saying though. That 0, I would.
I didn't try to rewrite that because I remember that like if we actually can have a plus 4 after, right? And if we have a plus 4, we have to do that twice.
Mm-hmm. Yeah.
So I didn't write that down because of that.
Mm-hmm. Zeros though, just to make sure we know what we're saying. The zeros are 0, 3, -5, -1. Not that that's what the problem asked us for, but just so our brains are staying on track. We could graph it if we wanted to from like the last test, using the end behaviors as a parabola, using the x-intercepts that we just found, crossing, or they all cross because they're all exponentially 1. That's kind of fun. We could do that. We're not going to do it, but we could. All right. Scroll through. Look for another hard one. That one is probably the toughest. Honestly, that's like the toughest thing on there. Maybe not. Maybe there's one more that's kind of tough, but that's one of them for sure. Getting that long division or the synthetic. What's up? What? 8? What's 8 look like? Sweet. 8's great. This is a good one. Okay. Try something different with this now. Now that it's crunch time and it's like, okay, I just need to know the answer for the test, for both tests. Let's try this. What is this 5 called? It's got a name. That 5 is called something really important. It's called a base, right? Okay, as soon as you see a base and you don't know what the answer is, you don't know how to solve it, don't even look at the other thing. Literally don't look at the other thing. Just think, what is the base? Bases usually have this thing attached to them. Otherwise, they're not a base. Don't look at that anymore. The word base usually has something attached to it. An exponent, right? Base, exponent. Those all went together. Otherwise, it's just a number. That's a number. That one's a base, right? So let's take our base and just write it as a base. 5. What's 5 to the 1? Cool. What's 5 to the 2? I'm not even looking at what the question asked me for. Literally not. What's 5 to the 3? Cool. Oh, okay. That's about as far as I can go. Unless you know 5 to the 4. You'll never have to. It'll always stop at 3 probably. 625? You don't need to know that. This one's not actually being asked, ever. But there's another type of exponent that could happen. Negative ones. So what's 5 to the negative 1? Yeah. 5 to the negative 2. Sure, because we're just using the thing next to it now to kind of fill this chart out. That we're not even looking up at the thing. We just know we had a base of 5, so I'm making a base of 5. They're the same word. They go together. I had a base of 5. I have a bunch of bases of 5 here. 1 over 125. There's actually one other type. There's only one other type of exponent. Yeah. 5 to the 1/2 is what? Square root 5. Well, I guess technically that means there's two other types. So what's 5 to the 1/3? Cube root of 5. So what about 5 to the negative 1/2? 1 over root 5, 5 to the negative 1/3. 1 over cube root 5. Those don't matter. But all we're going to do is go and look up, okay, well, now that we know it, we can fill out that chart, ugly as it is. Now I'll just go back up and look for my answers. Where's the 1/5 at? Right there? So what's my answer for that first one? This 1/5 only matches one of those answers down there. This one, right? So it makes your answer -1 and you're done. And this 1 over 125 only matches one of these answers. So -3 and you're done. Call it a day. And don't even worry about the ones that don't even kind of match. Like the other ones are just there. And if you see them later, then you can use them. Like, oh, cool, look, now I've got a negative where it flips to the bottom. Or now I've got a fraction where it square roots a number. All right, what else? Yeah, but y'all both had one, yeah? Number 10. Okay. This is just pretty darn easy, but only you only need to know one thing. You need to know how to get rid of that ln. Whoops. Oh well. You need to know how to get rid of that e. You need to know how to get rid of the e. So what's the opposite of an e? An ln. And literally that's it. That's the whole problem. Boop, boop, boop. But what you do to one side, you have to do to the other side. So we actually end up with this kind of thing where you go ln of e x plus 2 equals ln of 5. And the whole point of doing that ln was to make it cancel. So, boop, it's gone. It's literally just gone. X plus 2 equals ln of 5. Almost done. One last step. Yeah. Boop, boop. Literally done. Don't try to be a hero. I don't know what ln of 5 minus 2 is. I have zero clue what it is. Call it a day. If you had a calculator, you could type in ln of 5 and get something. I don't know what it beats me. Maybe like 3.1 or something. The trick there is to know how to get rid of the e. And that's going to come up later. If it does come up later, the idea is also, so if that's how you get rid of an e, then how would we get rid of an, let's say, ln of x to the, I don't know, a plus 2? How do you get rid of an ln? If ln gets rid of e, how do you get rid of ln? Yeah, you do this right here. E. And it cancels it out. So it's like flip-flops. That's a good problem, though. That's a pretty common looking type of problem, like not too complex. Like some of the other ones will have like a bunch of stuff after it, like plus x squared plus x. But this type looks a whole lot like the test does. Like that, just like 1 move, 2 move type problems, not like 6 move type problems. That was really 2 moves, the ln and the minus 2. That's pretty similar to the final. What else we got? Number 2. Sweet. They're all very different problems, but they're all really important rules, so that's probably why they're here. All right, number 2. Number 2 calls back a rule, like a log rule. And it's probably worth remembering. There's only 3 log rules, so it's probably worth trying to remember all 3 while we're here. So ignore number 2. There's only 3 log rules. There's log. I don't know. We'll just leave it alone, not even have a base. If you have log of a times b, what does that turn into? Log of a plus log of b. Love it. So that means the second rule is probably log of a divided by b turns into not a trick. Minus log b. And so the third rule, let's say log of a raised to the b better be you can take that little b, no plus, times. B times log a. Okay. So which of these rules applies to this one? You've got a plus on the outside. So that means you have a multiplication on the inside. Okay. So we get log 8 2 times x equals 1, which is log 8 of 2x equals 1. Or no? That's right. And now this is the same trick question as before, or the same one as the E, is how do you get rid of a log? How do you get rid of a log or an ln or anything like that? It's the same thing, just over and over and over. Not this time. But it's the same process. It's just not an E this time. What's this thing called right here? It's called a base. So you take the base and you make it a base. And that cancels it out. That's literally the way you cancel it out. That's it. That's how that goes away. But what you do to one side, you have to do to the other side. So we made 8 a base on the left, or exponentiated your argument by 8. So now we're going to exponentiate this side by 8 and end up with those canceling out. 2x equals 8 to the 1, which 8 to the 1 is just 8. So 2x equals 8. So x better be a 4. I believe it. Oh, that makes a lot of sense. Look at that. If you plug in a 4 right there, you get an 8 right there, right? And log 8. Looks like it would turn into 1. Oh, it didn't hurt. It was just closing. What's your question?
Can I solve log 8 of 2 without doing the multiplication?
Yeah, but does it help you?
I don't know.
Log 8. Yeah.
Like, so I have 1/3.
Over here, log 8 of 2. 2 is technically 8 to the 1/3, right?
Yeah.
So
Just like solve that, yeah. Plus log 8 of x equal 1.
So now you've got log 8 of x equals 2/3.
Yeah.
So now you've got raise 8, x equals 8 to the 2/3. The way you work a 2/3 is you do the top first. What's 8 squared?
Oh, I actually.
No, what's 8 squared? Oh, did you mess up somewhere before that?
I just did 2 cubed so I can multiply.
What? You got to get rid of the log, though.
I already did.
How?
I did. I have x equal 8.
Oh, you turned 8 into 2 cubes so you can cancel out the bottom? I mean, that's fine. Or you can go 8. Yeah, that's fine. That's cool. I know what you're saying. 2 cubed and cancels out the bottom. Yeah, that's right. It's just a funny, weird... If I were doing it this way, I would have just gone 8 squared is what? 8 squared is 64. To the 1/3 is 4 times 4 times 4, right? And there's how you end up at 4. Whenever I do those, you never go bottom to top. You always go top to bottom. So you go square it, root it. But I would have just done it the other way. I wouldn't have done that. What's up? What do we got now? Three. This is the same thing as the last one. Did you say 3?
No, that's good.
Okay, here. Try it for like 1 minute. Literally try it for 1 minute, and then I'll do it. Because ln is just a log, and it works just the same exact ways. ln and logs are exactly the same. They have all the same special rules. They have all the same thing going on. So, and I think it's actually good to do back to back. But it's the same rule too. It's not just the same type of problem. It's that minus turns into something. Oh wait, yeah. No, it's okay. Never mind. I was wrong. The other one had a plus. This one has a minus. But that's it. There's a rule that's really important. What's the rule? Which one? There's 3 of them. This one? That's the important one. These 2, I have no clue about. These 2 don't do nothing. Those 2 don't do anything. We don't even know anything about them. There's no special rule for those. There's only a special rule for no rule. No rule. Big rule. Big special rule for that one. So big ln. What goes on the top? Yeah. And what goes on the bottom? Okay. And then here's where you just have to know how to get rid of that ln. What gets rid of the log? Didn't we just say it? Yeah. I guess we didn't say it. I thought we did. How you get rid of a ln? You do this little e-base thing. Boop, boop. And it's not even like, oh, that helps get rid of it. Nope, that's exactly the opposite. It gets rid of it. Like, e is the opposite of ln. 10 is the opposite of log. 2 is the opposite of log 2. That's the only thing it is. It's not a different thing. It is the opposite to get rid of it. So now we've got x minus 3 over x minus 5 equals ln of 5. This is just algebra coming back to bite us in the butt. Solving for x when you have a rational function. What I'm looking for what you're saying cancels. Oh, I'm so silly. Thank you for catching that. I appreciate that. You're 1,000,000% right. But now I'm looking at this thing and I'm thinking I need to make a note. I need to make like a side note. It actually doesn't come into play. I've already done this problem today. Someone else picked this one. But it's still a good side note that I would always make. As soon as I get that thing right here, I got to make a note in my brain. That won't matter, but it's still important to make. What is the only weird thing about this? Okay, very super duper close. Yes, it could be less than 5. Because x could be 1 and get a negative number. Who cares? But x cannot be 5. If x is 5, the whole thing goes to crap. Like 5, I don't even know what to say. So off to the side, I'm just going to make a little note. X better not be 5. It's not going to matter. It doesn't matter in this problem. But if we work this whole problem out and at the very end we only got one answer and that one answer was 5, then we'd be in trouble. All right. But to keep going and get an answer, how do we get x by itself when we have 2 x's?
Multiply x minus 5.
Love it. On both sides, right? Yes. And what it'll do is cancel 1 out on this side and leave us with x minus 3. But it'll get us a cool distribution problem and go 5x minus 25. And now we're home free to solve this thing. X minus 3 equals 5x minus 25. That looks something like 4x equals 22. X equals 11 over 2. Zoom out a little bit. But the algebra on the bottom aside, the most important thing is that this is so easy to want to split up into 2 LNs. The green ones where I wrote no rule. It's so easy to see those 3 minus signs and forget which one of those gets the rule. There is multiplication on the inside, turns into addition on the outside. Division on the inside turns into subtraction on the outside. But subtraction on the inside doesn't do anything. We don't have a rule. It'd be cool if we did, but we don't. It's just there. We have to leave it alone. So that's the trick of this problem is they threw 3 minus signs and said, you better know which one to apply. Okay. What else we got? Number 4? No, we should not need number 4. You're doing it. We're doing these easy. That's okay. No, it's good. This is good to do. This is a whole day of review. Number 4. But because I have entire full confidence that you can do number 4, what's the first thing to do on number 4? Yes. Don't be trapped into thinking you need to L in it right away. Like that 8's left over from like maybe this 7th grade. Like we all know 35 minus 8. But they're just trying to trick us into thinking we need to L in it or something. But yeah, that's what it sounds like. Yeah, that's what I was actually thinking. I was like, oh, it's better than me. I could be. Just see that video? There was somebody doing the opera thing. It was on some. I don't have any of the things, but it was somebody was singing opera, and they left out a stanza because they didn't have the tenor 2 or whatever. But they were still going to perform the whole play, just minus 8 bars. And then someone in the audience just started singing it like really good to fill it in. And the lady on stage was like super grateful. She was like, "Thank you, actually. Like that actually helped a lot." It was really kind of funny. It was cool. Which I guess the people that would go to the opera would be the people that would know opera. But it was just funny to see it happen, and he did it really well, like better than everybody on stage. So the lady was like, "Thanks for doing that. We didn't have that part, but we wanted to play the play still." I don't know. I thought it was funny and sweet. 35 minus 8. 25 and 3 is 7. Right? Okay. Now here's where nobody knows what to do. Somebody else, Eric. Yes, but that's not what it's called. But yes, exactly. If you just do that on the paper, I'm okay with that. But that's not what it's called because you're not actually multiplying. You're ln-ing this whole thing. But if you remember it that way in your brain and you get it written down on the paper, I'm happy. So you're not technically multiplying by ln. You're natural logging the whole side. But what it does do is get rid of that e for us. So love it. So now we've got negative 4x equals the ln of 27. Do you know the ln of 27? I don't know the ln of 27. I only know the ln of e or things that have e in them. So we're done. X equals ln 27 over negative 4. Call it. Don't be a hero. You don't have a calculator on your test. You're just going to leave it there and write it there.
If we forget to put an ln in the answer, do we get it wrong?
What? Wait. No. It's multiple choice. So yes, if you circle the one that doesn't have L. The final.
Not the one. My solution. I wrote down.
Why do you always want to be different?
I have minus 3 divided by 4 and then 3 because 27 is 3 with her.
Okay, yeah, you can do that.
Okay, but is the answer or no?
Yeah, it's the same thing. This is what he said. He said, I applied that rule to it and did that. Yes. Good job. Thank you.
I don't know
I'm
in the exam it's going to be that one or the other one.
I don't either.
Okay, so.
Let me go see. That would be like an ln one. So basically what we're looking for. What? Basically what we're looking for is to see, did they ever leave a multiple choice question where you could have simplified it with the exponent on the inside, but you didn't? That would be the question. And there's only like 3 ln's or 4 ln's on the whole thing, so. 1 over, nope, that one doesn't. That one's simplified, but there wasn't an option to not do it simplified. It was just 6. So it's like, I can't. 6 is not anything. 11 and 3 inside of an ln, so no option there. Nothing in front of them. There's one that's simplified. But the whole point of the thing is simplify this. It says simplify this. So if you don't know to simplify it when it says, hey, simplify this log, like I'll show you. The one that I based off of that one would have been right there. Number 11. Look at number 11. Like, actually, let's just do, this is a good problem. Let's just do 11 real quick so you can see what I'm saying. Because you said, oh, you can simplify it because it's an exponent, right? Well, number 11 tells you, hey, I need you to simplify this, right? So hopefully, yes, you could stop a step short, but I think you can see where the step you're not supposed to stop at. Okay? So here's number 11. What rule of the 3 rules we have talked about like 3 times today applies to number 11? No. Anybody but you, really. What rule? We learned those 3 rules. What rule applies? Which is the multiplication turns into? Yes. So log of 100 plus log of x. And this is what I was saying for you, Destiny. Thinking like, could you leave it there? Yeah. Did the book leave it there? No. They simplified it. Because that's the whole point of this thing. It says expand and simplify. So.
Okay, but like before was just solve. I don't know what this means,
Solve means x equals, yeah.
Yeah.
Yeah, no, they're all pretty simple numbers. But there's one more big simplify thing that happens here. There's one thing that's a big simplify thing. That's really important to see. Yeah. So the first thing we could do with our brain is throw this little invisible 10 there so that we know it. And then the second thing we say is 10 to the 1 is 10. 10 to the 2 is, there's our bingo. Okay? So the log 10 of 10 to the 2 plus the log 10 of x leaves with 2 plus log 10 of x. Because that cancels. Shoot. But on the test, they won't write it like that because it's multiple choice. On the test, on a multiple choice test, what is the how, it's going to look very slightly different. What's the only difference that's probably going to happen there? If it's multiple choice and you see that, but it looks slightly different, how would it probably look slightly different? Yeah, it wouldn't have the 10 because that's just normal. I don't know. They just don't do it. Just like your iPhone doesn't do it. Nobody in the math world really does it. So it's good for us to have. I want to have it. I always have that 10 there so I don't forget the rules. But just being able to recognize in multiple choice, the 10 can come and go in and out. Totally okay. Sweet. Absolutely. Okay, let's see. We got log 5 x2 minus 4 equals 1. Probably just want to get x by itself. But there's a log stopping us. So the exact same problem, just doing it over and over again. How to get rid of the log. How to get rid of that log. I know I'm going to have to do something to both sides, that's for sure. Take a 5, you take the base, and you make it the base. And what you do to one side, you have to do that side. Cancels it out, so we're left with x squared minus 4 better be 5. And now we're at home free. X squared better be 9. So x better be 3. Love it. And I did put a hint there. Said, hey, look, there's 2 answers. Just as a hint. Because I mess that up often. I always forget to put the minus 1. Mm-hmm. Oh, sweet. This is a flashback. Flash from the past. All right. I think there were 5 things that we really have to know in order to graph stuff. There were 5 things we had to know. Let's do them real slowly in order. Doesn't matter what order, but we'll just take them one at a time. In order to graph something, you got to know 5 things. Any of those 5 things is what? The horizontal asymptote we achieve by looking at the first 2 terms. We go 2x over x squared. And we have the bottom exponent is bigger, which means the asymptote is y equals 0. Vertical asymptote. Oh, I shouldn't pick that. Anybody else can pick. Okay. What's the second thing we can do? There's 5 total things. Fine. And how do you find a vertical asymptote? You set the bottom equal to 0. So x squared minus 2 equals 0. Means that x squared equals 2. Means that x equals plus or minus root 2. There's your vertical asymptotes. There's your horizontal asymptote. 3 more things. Well, y-intercept? And how do we find the y-intercept? Yes. You set x equals 0. Not set the whole thing equal to 0. That's a different thing. Setting the function equal to 0 is different. Setting x equal to 0 just means you plug in 0, which is 2 times 0 over 0 squared minus 2, which is 0 over negative 2, which is 0, which gives us our y-intercept of 0, 0. Okay. What's a fourth thing? X-intercept. And how do you find the x-intercept? Well, really, you can even just say set the top equal to 0. Save yourself some time. It's kind of the flip of the vertical asymptote. But yeah, that's also setting the whole thing equals 0. Those two sentences are the same sentence. So 2x equals 0 means that x equals 0 means that we've got, the same point. We knew that already. We already knew that from our y-intercept. That makes sense, though. If it hits both, it has to hit both x and y-intercept on the origin. And the fifth thing is the harder to remember thing. Yeah. We just got to test some points at the end. But also, I think this one actually needs some in the middle, too. Once we graph, because of what the intercepts did to us, this one ended up needing some test points in the middle as well as the end. So let's draw it. Start with our vertical asymptotes at negative root 2, positive root 2. Horizontal asymptote at 0. Y-intercept, x-intercept at the origin. And now we need those test points at the end. But also, I think I need some in the middle, too. So the last thing is test points. All right. So what's a point to test? Pick the easiest ones. We already tested 0. Well, you should know. What? It's on the graph already. If I plug 0 in, I already have it, and it's big and blue in the middle. But I would try 1. What's f of 1? 2 times 1 over 1 squared minus 2 equals 2 over negative 1 equals negative 2. Right? Or did I mess up? Anybody checking that? Okay. So we've got 1 comma negative 2. Plot it. I think I know what's going to happen there. Let's try negative 1 real quick, though, just to be safe. F of negative 1 equals 2 times negative 1 over negative 1 squared minus 2 equals negative 2 over negative 1 equals 2. Negative 1 comma 2. Look at that. That looks like a shape we always draw. Okay. Now we need to do the end ones. What's another number to test? Negative 3, because it's way outside? Sure thing. F of negative 3 is 2 times negative 3 times negative 3 squared minus 2 equals negative 6 over, what's 9 minus 2? 7? Oh, shoot. That's a negative number. So what side of the axis is that on? The bottom side? So I know my graph is going to look like this. Last one. We're almost done. F of 3 equals 2 times 3 equals 6 over 3 squared minus 2, 7, top. Because it's positive. Those are the steps to graph a rational function. Unpleasant as they may be. It's pretty cool. It's pretty fun. I don't know how to graph that normally. Without a calculator back in high school, I'd just be like, I'll just grab my calculator and type it in. Now you know how to graph that? That's crazy. That's awesome. All right, what else we got? Number 5. Number 5's a good one. Number 5 we did like for one day, and then nothing on either side of that lesson was like even similar. So it was like, oh, cool, this is just a one-off lesson that's easy to forget. Solve the inequality and graph it on a number line. Usually when we have solve, we're solving for x, right? Let's just solve for x and see what happens. X squared plus 4x minus 2. Wait. 3. Let's get rid of that 3, huh? Move that 3 over. Is that a nice, neat factor? I think that's a nice, neat factor right there. 5 breaks down into freaking 5 and negative 1. Yes. 5, negative 1. X plus 5. X minus 1. Greater than or equal to 0. You're done. You're done. Hands off. We're done. We're going to go to the number line now. We're hopping over to this number line and we're drawing it. And we're plotting a point at whatever zeros we saw. So our zeros were negative 5 and 4, 3, 2, 1, 0, 1. 1. And how do we know what to do with these? They're either going on the inside or the outside. You know that. That always happens. That's like pretty much every single time. We just got to figure out if it's on the inside or the outside this time. There's 2 ways to check. One's easy, one's... What? Plugging numbers in. Absolutely, just plug some numbers in. So the easiest one I think is 0. It's sitting right there, right? And where do we want to plug them into? It doesn't matter. You can plug them into any line of those 3 lines right there. You can literally plug them into this, this, or this, and you'll still work out. I think I'm just going to do the top because it's the one we started with, so I know I didn't make a mistake. Because then you know you're not making mistakes if you plug it in the top one. So 0 squared plus 4 times 0 minus 2 is negative 2. Is negative 2 less than or equal to 3? Is that true? Is that a true statement? Yes. So it's going to get shaded, which means everything in here is going to get shaded because that's where our dots are. So we can kind of guess what's about to happen, but I think we have to check the other points just to be safe. So let's check 2. 2 squared plus 4 times 2 minus 2 is 4 plus 8 minus 2 is 10. Is 10 less than or equal to 3? Heck no. That's bad. So everything out here is bad. Because this one didn't work. And then I guess negative 6 is the easiest one to try over there. Negative 6 squared plus 4 times negative 6 minus 2 is less than or equal to 3. 36 minus 24 minus 2. 10 less than or equal to 3. Is that true? Heck no, it's not true. So these are all bad too. And then the only last question to ask yourself is, does it get curvy brackets or squared off brackets based on the sign? Based on the sign up there, it gets the squarey brackets. But I posit there's an easier way to do this. You don't have to do it my way. But here's my line of thinking. This is a shape right here. What shape is that highlighted yellow thing up here? This highlighted yellow thing that I'm drawing an arrow to is a shape. It's a parabola. And is it a happy or sad parabola? It's a happy parabola. So if I draw a happy parabola hitting those intercepts, watch this. Where is that happy parabola less than 0? All right here. And that co-aligns perfectly with those shaded areas we just drew. You can look at your parabola and know where that happy parabola is less than 0 based on that less than or equal to sign. Just a way to double check. So this is test point way. Watch this. I'll do this real quick. This is test points. And this is parabola. the parabola way, I would do the exact same thing almost. Just instead of testing points, I would draw my parabola. I would highlight the bottom. I would say less than 0. And I would say parabola is happy because of x squared. And so that tells me where to shade. Just a thought. Sweet. What else? Did I just randomly do number 10 up here instead of down there? Oh, well. You said 7? Ooh, 7 don't look fun. Oh, I have a note to make after we do 7, though. This is going to be fun. That we haven't even thought about once this year, but it's super nice. Okay, so it says find a 0. We already talked about how to find zeros, and then use it to find all of the zeros. So how do you find a 0? Not fun, but it is what it is. That TC over LC. So what's your TC on this problem? Your trailing constant or your trailing coefficient is the number 4 over 1. Here's your TC. There's your LC. So what? Here's a question, because this is actually on there. Is one of the questions on your final, I've looked at it already, will be find this little brackety thing. The whole... Not even solve it, just what are all the possible ones? Given those two numbers, what are all the possible things, top and bottom? So what are all the possible things? Plus or minus 1 comes from the 4, right? And plus or minus 2 comes from the 4. Because those are the factors, factor tree. And just plus or minus 1 on the bottom? Yeah. That's a question. Not this question, but that I saw that and I was like, oh, that's a question right there. Just to be able to do that with any two numbers. That's pretty nice. That's a gimme. And it's multiple choice, so you can kind of eliminate the ones that you think are not as nice. But that's not what we're doing here. Here we are actually solving. Anybody already do it? Did anybody already do it? No one that works? Which one works?
Oh, this one?
Oh, man. Okay, well, let's just try it. 1 goes into 1, 1, 4, 4. Drop it down. What? Yeah, you can group it, but I'm following the instructions because maybe the one on the test isn't as easy to group. So it said find a rational 0, then use it to find all the other ones. Yeah, you can group it. I'm not grouping it. I'm doing it this way. We'll get the same answer. You can group it. Go for it. But if the test doesn't have grouping, this is a good thing to know how to do. 1 times 1 is 1. 1 plus 1 is 2. 2 times 2 is 2. 6. What? It doesn't work? Well, dude, you're just perfect at it and you don't need practice? That's crazy, dog.
I said that we did that as first thing today.
Yeah, but it's still good to practice. 2, break it down. 1, 1. Oh, wait, those are all positive. That's the upper limit. Negative 1. Haha. 1, 1, 4, 4. Drop it down. Negative 1, 0. That 0 is what this problem's all about, probably. 4, negative 4, 0, check. As soon as you get that 0 at the end, I'm writing x minus up here. And that's my factor. X minus minus 1, also known as x plus 1. And then what do I have in the middle here? This is the point of this problem, actually, for real. This is x squared plus 0x plus 4. which is also known as x squared plus 4. So there's my factors right there. But can I break x squared plus 4 down even farther? Because it doesn't say find factors. We did that. That's our factors. It says find zeros. Yeah, we're going to have to do that, right? So what's the zero associated with this thing? -1, right? Or I guess better known as x equals -1. But this thing's got a different zero. Watch this. X squared plus 4 equals 0. What happens here? Don't just jump the gun. X squared equals -4. X equals the square root of -4. Now we've got a bind. Got a little hiccup here. What do we do with that? What do we do with that number right there? We take it out. We turn it into I root 4, which is literally just plus or minus 2i. There's my other two solutions. So my 3 zeros for this whole problem were -1, 2i, -2i. And it makes total sense that there's only 3 solutions, because if you look at the leading term, it's a cubic function. So there can only be 3 solutions. So actually that worked out super nice that it funneled into those 2 imaginary zeros. So that's the difference between when a question asked like this, when it said find a rational zero or find possible rational zeros, but then it said use it to find all zeros. And it didn't say all rational, and it didn't say all real. And if you take note of that when you're reading through this thing, and you're like, oh shoot, that says find every zero, not every real zero or every rational zero, you probably know something weird's about to happen like that. All right, what's up?
Why did you only do 1 and -1 for the synthetic dimension and not plus -2?
You could have. Just as soon as I got it, I stopped. I always just stop whenever I get one good one. Because once, so it starts with a 3 up here, right? It starts with a 3. I don't know how to do 3s. But then we get down to a squared. And no matter what the coefficients are, I know how to do a squared. Because worst comes to worst. Even if it's the hardest squared in the world, you know what you can do to solve it? -b plus or minus the square root of b squared minus 4ac all over 2a. If worst comes to worst, no matter what, like that's why I didn't keep going once I got one that worked. As soon as I got one that worked, I was like, oh, okay, I'll just quadratic formula it. I didn't need it this time because this series of things worked out nicely. But if you did need it, you could go straight up to here and go, okay, well, what was b? B was 0, so -0, because that's your b right there. This is a, b, c. Plus or minus the square root of 0 squared minus 4 times 1 times regular 4 all over 2 times 1, which would be plus or minus root -8 over 2, which would be plus or minus, wait, that's 16. Plus or minus, you got to take the negative out, I root 16 over 2, I 4 over 2, I 2. Plus or minus, there it is. So the quadratic formula spit out the same thing that the red solve did. Just took an extra step to do it. So that's why I stopped at -1. The long answer to what your question was a good question, but that's the long answer. Is because my brain thought ahead of time, oh, I got it down to a square. I don't need to do this hard thing anymore because I know at the very worst I can quadratic formula it. At the best, it just is an easy factor. At the very best, it's one of those little easy factors where you like 5, 1, we're done. It was a little in the middle this time. All right, what else we got? Don't have very much time or battery. Anyone other ones that look super tough? 12? What? No, here, we can do it real fast. Vertical asymptotes mean set bottom equals 0. So x squared plus 6 equals 0. So x squared equals negative 6. So x equals the root of negative 6. What? None. Would be your answer. There's no, you can't solve that. Well, I mean, you want to say there's a vertical asymptote at root 6i? I don't know where that is in the graph. You don't know where that is in the graph. I actually don't know. I'm not just saying that. Like, I don't know. I don't even know what it would kind of look like. There's no vertical asymptote. Okay. Let's do at least one more.
6.
Number 6? You said that with confidence. What? Okay, we're doing 2 more. We're still going to do 2 more. Horizontal asymptote, real quick.
What's the last one?
We've done every single one?
Yeah, so you said 6.
Oh. We just went way faster than my other class for some. I just talk faster, I guess. Okay, cool. Well, here you go. Horizontal asymptote. Boop-a-doop-a-doop. Look at the leading terms. They're the same, which means you use 4 over 1. So y equals 4 over 1. But here, real quick, before I let you go, I'll take a roll. The 3 cases for horizontal asymptotes are look at exponents, ... You look at the exponents, and if the top is bigger, what happens? This is important. If the top is bigger, it's infinity or none. Going on to infinity, that's not an asymptote. If it's the same, it's a fraction with the coefficients. And if the bottom is bigger, it's y equals 0. Not too wild. Okay. I did record this, and I actually recorded both classes, so if we went too fast,